For introduction, online shopping platforms like Shopee have transformed the shopping experience by offering convenience and access to a wide marketplace. The success of these platforms heavily depends on computational algorithms that ensure a seamless user experience. Algorithms in platforms like Shopee prioritize content based on relevancy rather than publish time. For example, the recommended posts on a user's homepage or search suggestion are determined by algorithms that predict what users are likely to engage with. In a competitive market where prices are lower than offline stores, customers are attracted to online shopping due to increased accessibility, such as the use of credit cards. However, with many online retailers, manually analyzing offers and choosing the best suppliers can be challenging. Algorithms help by dynamically adjusting prices based on factors like competitor pricing, demand, and inventory levels.
The application of computer mathematics. Online shopping recommendation system recommend items to users according to their preference and purchase history. Recommendation system employ algorithm developed based on linear algebra and matrix factorization techniques such as singular value decomposition. SVD decompose complicated data matrices such as user-product interaction into simpler components where patterns and preference identification can clearly be seen. The system can be chiefly categorized into two, which is content filtering and collaborative filtering. Content filtering relies on items that the user has liked to buy. There are various features such as price, color, types of goods, and etc. For example, customer enjoys purchasing black leather shoes, then the interface will prioritize items within the range. The system utilized when amplifying the metadata of items and aligning them with the user preference. Collaborative filtering based on user activities such as reviews and ratings alongside the purchasing history. The system seek out other people within neighborhoods with similar interests and make cross-recommendation of items that each person within the neighborhood had purchased that the other suggested. For example, user A and user B both are interested in sporting goods. It would be more appropriate for user A to receive a list of goods that user B purchased quite recently. Both types of filtering can be merged into one hybrid method, whereby a user is greatly benefiting with both filtering methodologies altogether. The hybrid classes of personalized recommendation will ultimately derive the preferable recommendation over those made by a single algorithm. Next is dynamic pricing. Dynamic pricing is a strategy where prices are adjusted in real time based on supply-demand trends, customer behaviors, and market competition. It uses advanced algorithms built on calculus and differential equations to optimize pricing. So how dynamic pricing works during high demand periods, which is festive sales, the prices will rise to maximize profit. During low demand, discounts are applied to attract customers and boost sales. Then this will give balance profitability with competitiveness. Next example of application of dynamic pricing. Take example for travel industry. Airlines adjust ticket prices based on booking patterns and travel dates. Meanwhile, e-commerce platforms like Amazon dynamically update millions of products prices daily using historical data and predictive analytics. The challenge of it is customer trust because frequent price changes may lead to dissatisfaction. So the solution to the problem is transparent pricing strategy. Ensure customers feel they are getting fair values. The benefit of dynamic pricing is that it lets companies gain revenue optimization, which businesses can maximize profit while staying competitive. Also, in market adaptation, prices respond quickly to to changes in demand and competition. For example, airlines adjust ticket prices, Amazon leverage predictive analytics to dominate e-commerce. Next is inventory optimization. The inventory optimization uses graph theory and probability model to efficiently manage stock levels, minimizing stockouts, product shortage, and overstock excess inventory. First, graph theory and inventory optimization. Model supply chains, warehouses, and delivery routes as a network of nodes, warehouse, and adjust transport routes. Algorithm like shortest path and minimum spanning tree optimize delivery route, reducing transportation costs and ensuring timely stock replenishment. For example, a company optimize its warehouse system by minimizing delivery costs between multiple locations. Secondly, the probability model in inventory management. It uses historical sales data to forecast demand and predict stock needs during specific season, promotion, or customer preference shift. Techniques like Monte Carlo simulation account for uncertainties, enabling business to prepare for varying scenarios. For example, forecasting demand for high-demand products during festive season ensures sufficient stock level while avoiding overstocking. So the benefit of this is cost efficiency, which is prevent tying up capital in unsold goods and incurring lost sales from stockouts. And dynamic adjustment combine probability models with real-time sales data to dynamically manage inventory. For example, Amazon used this method to ensure high demand items remain in stock while avoiding excessive surplus. The challenges of it is because it requires accurate data and effective algorithm to balance demand and supply. Uncertainty in consumer behavior also can complicate the prediction.
There are several problems that may arise without the implementation of computational mathematics. First is super-personalized recommendation. Without algorithms, Shopee would fail to provide personalized product suggestions based on user behavior, leading to irrelevant recommendations and lower conversion rates. Second is overstocking and stock outs. Without inventory optimization algorithms, Shopee could face overstocking or stock outs, affecting customer satisfaction and causing financial loss. Three is increased cart abandonment. Without algorithms to analyze cart abandonment and send reminders, Shopee would miss opportunities to encourage users to complete their purchases, resulting in lost revenue. And then ineffective search function. Without ranking and sorting algorithms, Shopee's search result would be inaccurate and poorly organized, frustrating users and reducing engagement. 5 is poor dynamic pricing and discounts. Without dynamic pricing algorithms, Shopee may struggle with pricing inefficiencies related to overpriced or underpriced products and reduced competitiveness. 6 is lack of fraud prevention mechanisms. Without fraud detection algorithms, Shopee would be vulnerable to fraudulent activities, damaging customer trust and causing financial loss. 7 is inefficient shipping and delivery optimization. Without optimization algorithms, Shopee's delivery times and costs could increase, leading to slower service, poor customer experiences, and reduced repeat business. 8 is about slow load times and poor scalability. Without optimized algorithms, Shopee's website and app may become slow, unresponsive, or crash during high traffic periods, negatively impacting user satisfaction and sales. 9 is missed opportunities for targeted marketing. Without data-driven algorithms, Shopee's marketing effort would be broad and ineffective, leading to irrelevant ads and lower conversion rates for promotion and discount. 10 is suboptimal customer support systems. Without algorithms, Shopee's AI-based customer support would be slower and more error-prone, resulting in longer response time and frustrated customers. 11 is failure in efficient product categorization. Without machine learning algorithms, product categorization would be inaccurate, creating a confusing interface and making it harder for users to find relevant items. 12 is inaccurate product reviews and ratings. Without algorithms to filter fake reviews, Shopee's platform could be flooded with misleading feedback, leading to poor purchasing decisions by customers. 13 is inefficient seller and product search matching. Without algorithms to match sellers with users based on relevant factors, Shopee could struggle to offer the best options, leading to dissatisfaction and reduced sales. And lastly is difficulty in handle multiple shops and pricing variations. Without an algorithmic approach, users must manually compare prices across multiple sellers, which is time consuming and prone to error. This leads to risk of overpaying or selecting products that are not the best in terms of price and delivery conditions.
This is my turn to discuss the solution to the problem we encounter in the online shopping. So here we have the one objective or one example. The algorithm described here is the shop and now algorithm, which aim to define the optimal selection of the shop to purchase or require products, minimizing the total cost. Let's break down and explain the step one by one. Move to the step 1 is the initialize the variable. So here we go to the bullet number 1. The variable f represent the minimum cost found so far, because no valid solution has been found yet. So bullet number 2 is the initialize the best solution, whereas the x is the set of products selected from shop 1. No product are selected from any shop, we denote as the empty set. Figure 1. Price of novel and delivery cost of 5 shop in the online shopping. So here you just leave off 5 shop you found in the online shopping with which novel you want to purchase. So here we can compare which store sell a novel at the cheaper price, and you can minimize your cost also. Step 2. Selection of shop and cart sequences. Try minimize the total cost by selecting a set of shop to buy the required products. Considering two things is the product cost and delivery cost. Shop selection. Each shop offers a set of product is N. We need to select a subset of product where each shop can either be included or excluded from the selection. There are two possible selection of shop. Validation of shop selection M. For each selection M, check if the union of product in the selected shop cover or require products. If N does not contain or require product, skip the selection. If N contain or require product, proceed to the next step. Cart sequence. Cart sequence here we can see the capital SM represent the product purchased from shop I in the selection M. Assignment of product. For each require product I, assign to the shop offering the lower cost of the product. The assignment or optimize using a chip structure with a store the cost of product in the shop and a low retrieval of the cheapest option. Cost calculation is a total cost, include product cost, delivery cost, and you try to minimize each cost you found in the online shopping. Figure 2. Price comparator solution. This is the result of the selection process we do in the step number 2. Here we try to minimize product cost by choosing the cheapest shop for each product. Delivery costs are constrained to the selected product in M. Final step, return optimal solution. Number 2, optimal cart sequence. After evaluating all possible shop selection, the optimal cart sequence is identified. The distribution of product across shop in the selection that minimize total cost. Number 2, minimize total cost. F, the corresponding minimum total cost included product cost, delivery cost. So this is the last figure, is the figure 3, is last step. Optimal purchase cost in the selected shop. All required product are purchased and total cost is minimized. Conclusion. Algorithm solution in online shopping optimization are transforming how customers make purchasing decisions by minimizing cost and simplifying the shopping process. these approaches and reshaping e-commerce and driving more informed, efficient and sustainable shopping experience.